So in this last section of 6.5, as always, we're moving on to applications. So there's two things that we're going to do. We're going to solve literal formulas. So solving a literal formula for a specified variable. And then we're also going to be solving two types of proportion questions. So the first thing you're going to be asked to do is solve a literal formula involving variables in the denominator. So rational literal formulas. So for this question, they want you to solve for p. To do that, we're going to do what we've been doing all through 6.4. So because this is an equation, I'm going to determine the lowest common denominator, which is FPQ. And then I'm going to multiply every single term by FPQ, so that I can destroy the denominators. So F gone, P gone, Q gone. And I'm going to see what I'm left with. So I'm left with PQ times 1, which is just PQ, 1 times FQ, and then 1 times FP. Then, what am I solving for? Well, I'm solving for P. What's the problem? There's two P's. We are back to a chapter 5 question. When you want to solve for a variable that appears more than once, get them together. In other words, I'm going to minus the FP from each side. So I end up with PQ minus FP is equal to FQ. Man, this sounds weird in my head. Then I'm going to look to see that these two terms have a P in common. So I'm going to greatest common factor out the P to be left with Q minus F, so that I can then divide both sides by Q minus F to be left with P equals FQ divided by Q minus F. Not easy, right? And then I wanted to give you a purpose for doing this. So oftentimes what will happen is that this is an equation for mirrors in physics. So there's like focal length, and then I can't remember what the P and Q stand for, but they're like distances from the mirror. And so what you could then do is that if they always gave you F and Q, you have an equation now to solve for P. So if I asked you to find P if F is 15 and Q is 25, I could have done that by putting the numbers in here and then rearranging. But now that I've rearranged my equation, I could just put them in. So I've got 15 times 25, and then I've got 25 minus 15. And then it's just calculator work. So I'm going to plug into my calculator 15 times 25 divided by bracket. So make sure you put your denominator in brackets or do the operation in your head. 25 minus 15, unbracket equals, and you get 37.5. So again, you're not going to do that all the time. Usually it'll just say solve for the specified variable, but I just wanted you to know that it's useful because then you're not having to rearrange the equation over and over and over again. You get to just put the numbers into it. All right, pause the video, give this one a go. So it's very similar to this one we just did, except I've put new numbers into my numerator. So can you take this equation and solve for Q? Well, the first thing is that my lowest common denominator is PQR. So I'm going to multiply every single term by PQR. PQR, PQR. And then I'm going to look to see what destroys. Gone is the P. Gone is the Q. Gone is the R. What am I left with? I'm left with 3 times QR plus 3 times PR is equal to 5 times PQ. Now I'm trying to solve for the Q, so I'm going to get the Q terms on the same side. And if you want to write yourself steps for this, like a question that looks like that, right? Step number 1, multiply by the lowest common denominator. Step number 2, get the Q terms on the same side. So that you can then factor out the Q. And then divide. So that my answer for Q will be 3PR divided by 5P minus 3R. It's really important when you solve these that there is no Q over here, right? Q equals all the other variables, but not Q. All right, let's try a few more. Actually, I think one more. So for this one, this guy's over 1. Again, I'm solving for a variable and I have variables in the denominator. So the first thing I'm going to do is find my lowest common denominator. For this one, it's big R plus little r. So I'm going to multiply both sides of the equations by big R, little r. And again, I'm allowed to do it because it's an equation. That will allow the big R, little r to get out of the denominator. I'm now left with A times big R plus little r is equal to big R, little r. Then I'm going to multiply the big A through. I get big A, big R plus big A, little r is equal to big A, little r, or big R, little r. Now I double check, what am I solving for? I'm solving for r, so my step's the same. I'm going to get the big R's together on the same side. I put lots of these into this note because I find in chapter 5 it's people's nemesis. Okay, I'm left with big A little r is equal to big R little r minus big A big R. Then I'm going to greatest common factor out that big R to be left with little r minus big A. And then I'm going to divide by little r minus big A. I'm left with big R equals big A little r over little r minus big A. Awesome. Hopefully that was enough examples that you're like, hey, this feels very repetitive. But the key thing is, from chapter 5, anytime you end up with 2 of the same variable, put them on the same side and then notice that they're in common, right? The key thing is noticing that both of these terms have a big R in common, so I can greatest common factor it out.